Hello everybody, welcome back. Today we're gonna go through two quick things, just very quickly. We have, if you can see here, I added a frames per second counter and FPS counter here, so we can keep track of the app performance overall. And then one thing that you cannot see here now, but we'll see in a second, is the UI here for the inventory is gonna be following wherever the player is looking. So let's really quickly see those two in action. Let me just bring up virtual desktop so we can see this in VR. Alright, and we are here in VR. As you may see, we still have our debug line here, but now we have this nice frame counter floating around. Cool, if you remember from the last video, we hide the inventory UI by default, and then we have a button press that we're checking for to display. So let me just push that, and that should bring up the UI. Boom, there it goes, flying in. So hopefully you can see that in the view, it's actually following the camera. So depending on where I'm looking at, the UI follows, but it's not attached like the debug line and the FPS, because in real game performance, having something big like the UI completely follow the player's gaze can be quite jarring and can induce some motion sickness. So it's good to have it appear to be its own element with its own movement, not just attached to the view. So that's why we have the UI kind of trail back the movement and follow wherever the player is looking. But that's it. It may not show directly in the middle of the view in the scene here, but inside the headset is smack down the middle, so it's pretty easy to access everything here in the UI. And of course it still works as before. You can bring it back up at any time, and whenever we disable it, it stops updating its position, so it kind of like sticks around. Then when we bring it back up, it sort of floats in from wherever we last saw it, which is kind of a cool effect here. We'll have to see what happens when we move a great distance without updating the UI position. You can see that flying in from a great distance. So depending on the follow speed, that may be too much. But anyway, that's how it's working right now. So let's see how we can make that happen. Let's go object by object and see the changes here. One of the changes here is the FPS text. This is pretty much a copy of the debug test if you've seen it before. It just has a canvas here, and we have this FPS text component. Here has an update interval. We're checking twice a second. And then we have a couple of instances here. You probably couldn't see it in the headset directly, but whenever the FPS drops below 70 here, it turns yellow, and if it drops below 60, it turns red. Which is just a nice touch to keep in mind, because yeah, we want to be hitting 72 frames per second consistently. But yeah, let's quickly look at that script. I'm not going to go into details about everything here, but you can see that I have these three config flows here, just how often we want to update it and where we want those thresholds to be. And then we're just tracking the text component itself, and then we have a few variables here to track state. We set up the text, and then every update we call the update FPS. And then we have a few helper methods here to change the text and the color of the text. But really quickly, the main thing about frame counters is just keeping track of time. The time.delta time is how much time has passed since the last frame. So we track that in time left. And then in accumulated time, we are adding the time that has spent. We track time left because we want to know when we need to check for frames again, when we're actually turning the accumulated time into a frames per second count. And then we're adding a frame every time. We call this method, which means that every update cycle, we're going to add a frame. Then if the time left is greater than 0, we just continue accumulating time. We don't want to do any calculations until we reach the update interval. Once we reach the update interval, then we do the calculation. We do the number of frames divided by the accumulated time, and that's basically the frames per second. Right? If the interval is 1 second, it's just how many frames have elapsed. If the interval is, twice a second, then we basically are dividing this by 0.5, so we're duplicating the count of frames, and so on. And then we just put that into the text, and then we do the color setting according to thresholds that we set up, and then we refresh the state here to start the cycle again. Pretty straightforward. Then the other change that we've added here is to the inventory UI. Here we added the follow transform component here, which has a transform that is looking at where the UI in this case will be looking at, which in our case is the central anchor, which is basically looking at the camera. And then we have a transform to follow. This will be the position that the UI will be trying to get to consistently, because we don't want it to just attach to the camera itself, because then we couldn't see it. We need to attach it to a point in front of the camera. So that is the UI offset here. And then we have a follow speed here, which I set with a float variable so we can control it separately, because we may have a number of UIs that will have this behavior. So it would be better to set that up in a variable there. So let's quickly look at the offset before going into the script itself. So here we have the UI offset. This set up 1.5 units in front of the camera, which we could think of 1.5 meters, right? Which should be about like 5 feet. So that's how much in front the UI is going to be. And we can tweak that to pull the UI in closer or put it out further. Since it's an object in 3D, it can get occluded. So if you have a lot of elements closer to the player than this 1.5 meters, then the UI may get clipped. So you have to keep that in mind for usability. And then we can start talking about shaders and how you can make a shader for the UI so that regardless of its 3D position, it's always rendered in front of other elements. But we may get to that at a later time. For now, I'll just quickly look at the actual follow transform. So here we have the follow transform. Is again pretty straightforward, just a bunch of math. Unfortunately, we have here the transform that we want to be looking at, in this case the camera, with the transform that we want to follow. This is the point in front of the camera that we want the UI to continuously try to match. And then we have this float reference as the follow speed, which basically is how much do we want the UI to try to follow the transform. If it's very fast, then it will seem to be attached to the transform that we're following. And if it's too slow, it may just take forever for the UI to kind of get in position. Because if it's not in position, it's not really useful. So this is something we may want to tweak specifically, and that's why I made it a float reference so we can tweak it easily for all UI. Then we're caching the local transform here just because every time we call transform, this is a component lookup, and then that can get expensive. So we just look it up once and then cache it here. And then every update, we are doing a few calculations, right? We first have the transform of the object as following. Look at the other transform that I want to look at. And then we're setting this vector here, which is the world up. Basically make sure that the UI is actually like pointing up. It has the right normal. Then, because of how UI works, usually the Z axis ends up looking away from the player. So if we just have the UI look at the camera, it will be in front of the camera and it will be kind of looking at the camera, but it will be flipped around. So the way that we adjust for that is that we rotate by 180 degrees on the Y-axis, and that basically just flips the UI around and makes it look at the camera, but with the right orientation. And then we need to calculate where the UI needs to be. So for this, we have a new position, and then we have also cached the follow position here from the follow transform. It's again just to save us some time looking up the transforms here. And then we are setting the X, Y, and Z for the new position. We are just interpolating the position here. So we know where the UI is currently. This is the new position here. And we know where we want it to be. The only thing is like how much do we want to move the UI in that direction. And that is basically follow speed times time delta time, so that it has the same speed regardless of frame rate. Follow speed here, we didn't see that, but it's set up to 1 right now. We could change that later. But for this, it doesn't matter. We're just saying we want the position to be this follow position, but we're not immediately moving it there. We're just moving it by a small amount. And this is determined by the follow speed and the time delta time. And that's how linear interpolation or lerping here works. So we do that for X, Y, and Z. And then we just set the position to a new position. And that is all that we need to do. We have the UI looking at the camera and following the player. And just a reminder here, I'm not gonna put on the headset, but you should be able to see it pretty easily here. Just bringing up the UI. There we go. Cool. So now you can see that's following the camera around here. If we put on the gizmos here, you can see here's the camera, and then wherever we move it, the UI follows. Cool. So that's it for this video. Really quickly, just wanted to show that to you. In the next video, we'll be following up on other merchant interactions and many other things that we have left for the project. But for now, that's it. Thank you for sticking around with me, and see you in the next one.